3, day 14.5 homework assignment. It says find the equation of the tangent line to the relation at the given point. So you guys know for an equation of a tangent line, all right, you need two things. You need the point and you need the slope. Then once you have that, you could do point slope form. So for these questions, it looks like they gave us the point. So we just have to find the slope. We have to find the derivative, all right, and then we could plug the point in to get the slope. So if we take the derivative of each term separately, we get 16y dy dx minus 6x squared equals 4. So we have to get the dy dx by itself. So we can add 6x squared to both sides. So these 6x squareds cancel. They really just disappear. All right, and then we could divide both sides by 16y. So the 16y's cancel, and that's what we get for our dy dx. So to actually find the slope, we have to evaluate dy dx at the given point, -1, 2. So we have to plug in -1 for x and 2 for y. So if we do that, we get 4 plus 6 times -1 squared all over 16 times 2. -1 squared is 1, so we really don't need that. So 4 plus 6 is 10 all over 32. And if you reduce that, you get 5 over 16. All right, so 5 over 16 is really your slope. We need to use this point and combine them into point slope form. So y minus 2 equals 5 over 16, x minus a -1. All right, and you can, of course, clean that up and change them to positives. Double negative turns to a positive. Each term separately, so derivative of 2x is 2 minus 8y dy dx equals 6 dy dx. So we have to get all the dy dx terms on one side of the equation. So I would add this 8y dy dx to the other side. So these cancel. Save time. I'm just going to erase them. All right, so really we have 2 equals all this, and both of these terms have a dy dx in them, so we could factor a dy dx out and write what we're left with, 6 plus 8y. And then to get that by itself, all right, we need to divide both sides, all right, by 6 plus 8y. So these cancel, and this is what your dy dx equals. All right, so to find the actual slope, we need to take our dy dx equation and evaluate it at our point, -4, -1. So we're plugging in -4 for the x and -1 for the y. So our equation, I just kind of switched sides here, was 2 over 6 plus 8y. Our y was -1. All right, so if we do that math, that's 2 over 6 minus 8. 6 minus 8 is a -2, so 2 over -2 is really -1. So -1 is our slope, -4, -1 is our point, and we just have to combine them to get our point slope form. So y minus a -1 equals -1, x minus a -4. Lots of negatives there. You can, of course, change the double negatives to positives. And that right there would be your final answer. Y plus 1 equals -1, x plus 4. Where the relation has vertical tangents. So let's think about this. If you have a vertical tangent line, all right, that means your slope is undefined. And think about what kind of numbers get you an answer of undefined slope. It's always a number over 0. All right, right? If you have 0 in the denominator, we consider it undefined. So basically, we got to find our slope or our derivative and set the denominator equal to 0. All right, so first, find the derivative. All right, so if we take the derivative of each term separately here, derivative of -3x is -3 minus 2 dy dx equals 6y dy dx. Of course, we have to get all the dy dx terms on one side together. So we can add this 2 dy dx to the other side. So these cancel. All right, and we are left with -3 on the left, and on the right, both of these terms have a dy dx in them, so we could factor a dy dx out, and we're left with 6y plus 2. And then to get dy dx by itself, let's divide both sides by 6y plus 2. So that right there is our derivative equation. All right, and we need to evaluate that. Well, not evaluate. We need to figure out the x and y's where this relation has vertical tangents. So we said what would make this have a vertical tangent is if the slope, or our derivative, all right, has a denominator of 0. So we need to set our denominator equal to 0. So this was basically step 1, finding the derivative. Step 2 is to take our denominator, 6y plus 2, and set it equal to 0. If the denominator equals 0, then the derivative or the slope will be undefined and we'll have a vertical tangent. So if we subtract 2 from both sides, we'd get 6y equals -2. Divide both sides by 6, we'd get y equals -1/3. All right, that's your y coordinate. All right, we could check that off the list. We need the x coordinate now. So think to find the x, you always plug the y back into the original. So we're going to take this original right here. All right, it is -3x minus 2y equals 3y squared. And we have to plug our y value in for both of these y's. So -3x minus 2 times -1/3 equals 3 times -1/3 squared. All right, and we got to solve for x. So we get -3x. The double negative definitely turns to a positive here. All right, and we could call this 2/1. So we'd get plus 2/3 equals over here. A negative squared is a positive. All right, so we're going to get 3 times 1/9. So we really have -3x plus 2/3 equals, that's 3/9 or 1/3. And then if you subtract 2/3 from both sides, we get -3x equals -1/3. And then to solve, you can divide both sides by a -3. So we get x equals, and there I would probably make this -3/1, and I'd do my outside inside trick. First of all, negative divided by a negative is a positive, but the outsides, 1 times 1 is 1. The insides, 3 times 3 is 9. So you'd get x equals 1/9. So really the point there, the x is 1/9 and the y was -1/3. This is that point, all right, where our relation has a vertical tangent. That right there would be our final answer. Previous one, it said find the x and the y coordinates where the relation has vertical tangents. So again, a vertical tangent means the slope is undefined. And how you get an undefined slope is when the slope has a denominator of 0. So we have to find the derivative, set the denominator of the derivative equal to 0, and solve. So step 1 is definitely finding the derivative. So we get 2y dy dx, the 1 is a constant, just disappears, minus 2 dy dx equals 4. Both of these terms have a dy dx in common, so we could factor that out. So we're left with 2y minus 2 equals 4. All right, and to get the dy dx by itself, we divide both sides by 2y minus 2. And those 2y minus 2's cancel, and I'm just going to erase them. This is our dy dx. All right, we said if we want a vertical tangent, our derivative, dy dx, or our slope, has to have 0 in the denominator. So step 2 is taking this denominator right here and setting it equal to 0. So 2y minus 2 equals 0. If we solve it, we get 2y equals 2. Divide both sides by 2. You get y equals 1. All right, that is part of the answer. They want the x coordinate as well. All right, so to find the x coordinate, we could always plug that back into the original relation. So step 3, our original relation was y squared plus 1 minus 2y equals 4x, and we're going to plug in our y value. So 1 squared plus 1 minus 2 times 1 equals 4x. So 1 squared is 1. 1 and 1 is 2. So it's 2 minus 2 equals 4x. We get 0 equals 4x. Divide both sides by 4. All right, and you get x equals 0. So we needed the x and the y coordinate. If you want to write it nicely as a point, the point is 0, 1. That right there would be our final answer. That is the point where our relation would have a vertical tangent. X coordinates of the points where the relation has horizontal tangents. 1, make sure you read. It only asks for the x coordinates, didn't ask for y's, so don't waste your time finding the y's if you don't have to. So it wants to know where this relation has horizontal tangents. And think about a horizontal tangent means the slope is 0. Or in other words, our dy dx is 0, right? A horizontal tangent has a slope of 0. So we got to find the derivative and set it equal to 0. So step 1, if we find the derivative, I'm just going to copy the relation. It's x to the third plus 3y squared minus 9x equals 2y. All right, so if we take the derivative, we get 3x squared plus 6y dy dx minus 9 equals 2 dy dx. All right, and we want to get the dy dx's on one side of the equation by themselves. So I would subtract the 6y dy dx to the other side. So those cancel, or in other words, just kind of go away altogether. All right, so we are left with 3x squared minus 9 on the left side. On the right side, we could factor a dy dx out. So we're left with 2 minus 6y. And then to get dy dx by itself, we can divide both sides by 2 minus 6y. 2 minus 6y's cancel, and we're left with our dy dx. All right, so we need dy dx to equal 0. So step 2 is going to be to set dy dx equal to 0. So we just found our dy dx. It's 3x squared minus 9 all over 2 minus 6y, and we got to set it equal to 0. All right, to solve this, think 0 can really be 0 over 1. All right, 0 divided by 1 is 0. All right, so we can really just cross multiply. If you cross multiply, you get 3x squared minus 9 equals 0. And if we solve this, 3x squared equals 9. Divide both sides by 3. You get x squared equals 3. And if you take the square root of both sides, you get x equals plus or minus root 3. All right, and I think that is your answer. They just asked for the x coordinates of the points where they have horizontal tangents. You do not need the y's. You know, if you did need the y's, you'd have to plug the x's back into the original and solve for the y's, but you don't need them in this case, so don't do more work than you need to. Number 6, if f of x is increasing, decreasing, or constant at 1, justify your answer. So I kind of put this chart in blue over here that we've been talking about. We know when the original function is increasing, the derivative is greater than 0. All right, we know when f of x is decreasing, the derivative is less than 0. So it might be helpful to kind of use these rules because I don't know about you guys, but I have no idea what this graph looks like. All right, so, you know, if I can't take out a calculator and just look, you know, at 1, is it going up, down, or is it a straight line? Then I don't know how to do the problem. So it's probably easier to use derivatives to help us. So what we're going to do here, all right, we're going to take the derivative. definitely going to involve chain rule. All right, this negative 2x plus 1 is the inside function. All right, so we got to take the derivative of the outside function first. The negative is just a constant that hangs out. All right, derivative of e is itself, and chain rule says leave the inside function alone and then multiply by the derivative of the inside function. So derivative of the inside function is negative 2. All right, and I would probably clean that up. We're going to have to plug in 1 into this and see what kind of number we get, positive, negative. All right, so I'd probably clean it up. So let's rewrite it one more time. All right, the two negatives in there, negative and a negative, are going to turn to positive. I might put the 2 in front. Let's call it 2e to the negative 2x plus 1. All right, so now if we want to know increasing, decreasing, constant at 1, let's plug in 1. F prime of 1 is 2e to the negative 2 times 1 plus 1. All right, so we get 2e to the negative 2 plus 1. Or negative 2 plus 1 is negative 1. All right, and really, we don't like to leave negative exponents in our answer, so that negative exponent is on the e. So I'd leave the 2, but I'd bring the e to the first power to the denominator. All right, so really we get 2 over e. All right, that is a positive number. All right, think about e is the number 2.71. That's about 2 over 2.71. All right, whatever number that is, it's a positive number. All right, so since our derivative is a positive number, derivative is positive, that means our original function is increasing. So increasing is the answer. F of x is increasing at x equals 1. And we can write how we know. It says justify your answer. We'll say since f prime of 1, we did that math, since it was a positive number. Since it's greater than 0 or positive, that's the shortest way of writing your reasoning. All right, if it was a negative number, we would have picked decreasing. All right, increasing was if f prime was greater than 0, a positive number. Decreasing was if f prime was less than 0, a negative number. And then think about constant. If a function isn't increasing, if it's not decreasing, constant would mean, say your function is a straight line. All right, straight lines have a slope of 0, or in other words, a derivative of 0. So if we got 0 for that number, it would have been constant. All right. As is g, increasing, decreasing, constant at 1. So same thing. All right, we're going to use a derivative to help us because, I'm not exactly sure, negative 8x to the third plus 3, all right, what that graph looks like. So let's use a derivative. So if we take the derivative, bring the 3 out in front, 8 times 3 is 24, so you get negative 24x squared. The 3 is a constant, so it disappears. And if we plug in 1, g prime of 1, you get negative 24 times 1 squared, or negative 24. So negative 24 is a negative number. All right, so think about what that means. All right, if your derivative is a negative number, that means your original function is decreasing. So we can say g of x is decreasing at x equals 1 since g prime of 1 is a negative number or less than 0. That's probably the shortest way to write your answer and explain it. All right, so just be careful here in the middle. This 2x times y is going to be product rule. I think the rest of it should be pretty easy. All right, so let's do each term separately. This first one, if we bring the 3 out in front, you get 6y squared times dy dx plus, now we need to do our product rule. Derivative of 2x is 2. Leave the y alone. Plus, leave the 2x alone. Derivative of y is 1, but you need a dy dx after it. Derivative of negative 3x squared is negative 6x equals, on the right side, derivative of 7x is just 7. And we need to solve for dy dx, so we need to get all the dy dx terms on one side of the equation by themselves. So I think I'm going to leave those on the left side and move the other stuff to the right side. So this 2y, we could subtract 2y to the other side. So those cancel. And then the negative 6x, we could add it to the other side. So those cancel. So with our dy dx, we can factor the dy dx out of the terms that are left on the left side. So we're left with 6y squared plus 2x. And on the right side, we have 7 minus 2y plus 6x. And then to get dy dx by itself, we have to divide both sides by this quantity, 6y squared plus 2x. Right, and that right there is our dy dx. Right, if you chose to move all the terms to the opposite side of the equation, you would have the opposite answer as me. So another possible answer would be if all the signs were flipped. If you had negative, positive, negative, negative, and negative, that would be correct too. All right, really either answer, you could have those signs I have on my screen right now, or again, you could have all the opposites, and that would be correct as well. Below, evaluate the following, and these are a little bit hard to see, but there's a prime here. So this is the derivative of the inverse. So remember, there was a special formula for that. It was 1 over the derivative of the inverse of 0. So you got to figure out what the inside is first. So we really have 1 over f prime, and we got to figure out what that inverse of 0 is first. So I would almost take that off to the side and say, the inverse of 0 equals what? Inverses always switch the x and the y. So if you wanted to write it as f instead of the inverse, it'd be like f of blank equals 0. We're looking for the x that has a y value of 0. So what x value has a y value of 0 for f of x? Y value of 0 for f of x is an x value of 1. So that's an x value of 1. So in the parentheses is really a 1. All right, so next step, finding f prime of 1. All right, if you look in the table, the f prime column, f prime of 1, it is 7. So that answer would be 1/7. A little bit hard to see, but same thing, derivative of the inverse. So the formula was 1 over the derivative of the inverse of 1. So we got to figure out what the inverse of 1 is. So again, I would kind of take that off to the side and say, the inverse of 1 equals blank. If you reverse it, it's really f of blank equals 1. We're looking for the x value that gives a y value of 1. So a y value of 1 is the x value of 2. So really 2 is going to go in that parenthesis. So it's 1 over f prime of 2. All right, so now we got to figure out what f prime of 2 is. If you look at the f prime column, all right, and the 2 row, f prime of 2 is 12. So that answer is 1/12. Of the inverse of 2, again, it's 1 over f prime of the inverse of 2. And I would figure out that inverse of 2 first. Kind of running out of room, I might erase up here. So I can do that inside function first, right? Inverse of 2 equals blank is really like f of blank equals 2. We need the x value that goes with a y value of 2. So a y value of 2 goes with an x value of 0. So we really have 1 over f prime of 0. And in the table, f prime of 0, this is f prime right here. F prime of 0 is really a -4. So this would be 1 over -4, or -1/4 for your answer. Prime there, I know it's hard to see, all right, but it is the derivative of the inverse. So the formula would be 1 over r prime of the inverse of 10. So we need to figure out what the inverse of 10 is first. So I'm going to kind of take that off to the side. For the inverse of 10 equals blank is really r of blank equals 10. All right, you're looking for the x and you're given the y. All right, or in other words, you can just put an x in there. All right, we're looking to solve r of x equals 10. What x value can we plug in to get 10? So you could actually just substitute r of x in there. We know r of x is 3x plus 1. Set it equal to 10 and solve. Subtract 1, you get 3x equals 9. Divide both sides by 3, you get x equals 3. All right, so the inverse of 10 is 3. So we go back to our original problem. We had 1 over r prime. We were trying to figure out what that inside function was, the inverse of 10. It was 3. All right, so now for the denominator, we need r prime of 3. So first, find r prime. Derivative of 3x is 3. The 1 is a constant, just disappears. All right, we don't even need to plug 3 in. R prime of 3, there's literally no x in there, so it's just 3. So 1 over 3 is the answer, 1/3. F of x, that's the black function in the picture, and its tangent line at 1, the tangent line is red, is graphed below. Evaluate the following. So f of 1, just the point on the graph, this is f of 1, it's 3. F of 1 is 3. All right. Next is f prime of 1. Think about what that means. That's the derivative, or the slope of the tangent line at 1. So we need the slope of that red tangent line. All right, they gave us a point on it. This looks like another nice point. I would just do rise over run to find the slope. It looks like it's down 2 over 1. So down 2 over 1, negative 2. All right, and the last question, derivative of the inverse of 3 times f of x. Let's just change that. I'm not sure why it says that extra f of x there. I think that is a typo. So let's get rid of this f of x. Let's pretend like this part isn't here. Sorry about that. All right, let's just do derivative of the inverse of 3. If it said that, you guys know the formula. 1 over f prime of the inverse of 3. So of course, you have to find the inverse of 3 first. So I do that off to the side. Inverse of 3 equals blank. That's really f of blank equals 3. So we're looking for a point on the graph of f, that black graph right there. We want to know the x value when the y value is 3. So when the y value is 3, the x value is 1. All right, so that inside function is 1. So we really have 1 over f prime of, we just said that whole inside is 1. All right, and then we need f prime of 1. Well, we found that up here in part B. F prime of 1 is negative 2. So 1 over negative 2, so negative 1/2 is your answer.